Thank you so much, Charles. Yeah, lovely to be here. Unfortunately, I cannot be there in person, but I hope we can have a fun conversation online itself. So, yeah, I'm not going to introduce myself. Hopefully, Charles has given a bit of an introduction. So, today's presentation is going to be, it's not going to be all sunshine and rainbows. It's not going to be a very fun one for a lot of stakeholders in the industry. But I think maybe that is what we need to do and have a difficult discussion at some point. So the discussion topic is crash testing the circular economy. Just a couple things. I hate making presentations, so this is something rough and but it should be fun enough. And then I've put up a bit of numbers and different images that should take us around. But yes, but if we move to the first slide, let me see. Yeah. So I'm sure everyone sitting there and otherwise in the industry has seen this image. Of course, the linear, the recycling, the circular economy, and it looks great. Of course, this is a very good representation. It is, from my own perspective, it's a very flawed way to represent this. Nowhere in the industry do we have just these straight lines and it works out so well. And of course, the circular economy diagram is a very fun theoretical diagram to make. There are no lossless closed loop systems anywhere on the planet. It just doesn't exist. It's a theory. Any diagram that any sorts will have some losses coming out somewhere. You can't have a perfectly closed loop system. So this, even though it's a good representation, it's a very linear, two-dimensional kind of photograph that doesn't really tell us much about the industry. So I wanted to see if I could translate that into something else. So of course I'm a big Marvel geek, and I love the TV show Loki, and I think I've done a post about this as well. So if you see the diagram on the top, that I would say is a much better representation of what the linear economy looks like or looked like in the past, a few decades back when we had fewer players in the industry. So if you see the middle white line, of course not a straight line, that I would say was when the brands used to own the production. They had much more control. They would make the products, sell it, everything was with them. And then we were slowly starting to phase out into different branches. We had suppliers moving into Asia and other places, and you didn't have your own manufacturing completely. And then we had the red lines, and not much was beyond the red lines. But as years have passed and we've moved on decades after, this is the bottom image is what the current linear economy would look like from the perspective. So we still do have certain brands who might have control. It's a thin white line in the middle. And then we have a lot of branches. And of course, these branches are growing branches of their own as well. So now we have contractors and we have subcontractors and even other players involved. And the red lines are more so the indicative lines for things that we know and things that we don't know. So you give a contract to your supplier and they give it to someone else, and then it goes beyond the red line and you don't have much oversight. And this is what the linear economy kind of looks like. It's not a straight line that you just pick from one end and bend and turn into a circle. It just doesn't work that way. It's a very complex structure of multiple thousands of suppliers, thousands of brands, thousands of different products. So it's just not about bending one line is going to work out. All of these additional lines and branches resist change. And for it to happen, we need to move to a different structure altogether. But yes, moving on to the whole aspect of circular economy. Uh, this this is what the circular economy should be, and this is the smaller circle is what the industry does. Chasing circular materials doesn't mean you're chasing circular economy. Circular economy is a way of doing business for that matter. And I have my own personal definition wherein I say that it's a way of doing business wherein you're able to grow and everything else, but within the regenerative limits of the planet itself. So you can do it in any means necessary, all the R's and other methods that you can play, and not just for materials, for everything that we use. And it can be social elements, it can be water, it can be energy, it can be chemistry, it can be anything else. So if the industry wants to have a circular economy, we need to move our definition beyond materials. If all you have is a recycling strategy for your materials and your fiber targets for 23, maybe let's stop defining it as we have a circular strategy. We have a circular material strategy, and that should be what should be on everybody's sustainability reports. You don't have a circular economy strategy, you have a circular material strategy. So you're doing part of it. Nothing wrong with it, but yeah, maybe it's time we define it much better. But then if we come back to the industry, and of course, we want to see where we are in the industry and how far we've come along and what we've done. So of course, Apparel Impact Institute has done phenomenal studies and they publish this data every year that comes out. So we see 2019, we were quite far back. The values were much lower. Now we've come far up and the values have gone up significantly. Of course, from the 2019 levels, we want to keep it at a 45% reduction. So we want to be at this 0.489 gigaton mark. But the way business is going right now, we're constantly seeing an increase. And of course, this data is for 2023 because we run slightly behind in terms of publishing the report. In the last 2 years, not much has happened that has indicated any sort of us going down. So when the data for next year and the data for the year after comes in, we will more or less be going along with it. So first we had 11 years to get to the target. Then we had 10, 9, 8, and now we're down to 5. Next year, we're going to be down to 4. So we're going to have 4 years to get to this reduction. And it's going to be a humongous problem. And of course, we all speak about, how textile waste is the elephant in the room. Maybe, may not be. I don't think it is, because even though if it is, then we have a much bigger apex predator that we don't necessarily see. And it's quietly there dismantling everything that is possible on the planet, not just in one area, but in every avenue of society. And we want to address the elephant in the room, but if we just keep pursuing that, we might miss out the bigger predator that we have, who's going to cause much more damage. But if we zoom into the industry and where the challenges come, I've read so many articles and posts and everyone else saying, materials make up 80% of the impact, or design of the product makes 80% of the impact. That is a gross misinterpretation of, or misrepresentation of how we see it. When they say materials, they say the end product. So, but they just use the word materials, which conveys to the rest of the industry that, oh, the material itself is causing so much impact. Not necessarily. When AI did the study, the raw materials make up only 22% of the impact. So getting the fibers, getting the pellets and everything else from petrochemicals, 22%. The rest of what happens to it accounts for the 78% of the impact. And we barely touch the rest of the 78% under different variety of excuses of, it's very complex, it's too fragmented, all because of our own doing, all very easy to solve. So we can see, of course, that is about 208 million tons or something of the material side of things. And as we saw in the previous slide, we want to get down to 0.489 even from the current levels and everything else we see. So if we go to the next slide, so to stay within the trajectory, we need to go down from 0.944 currently to 0.489. And of course, we're going to be higher than 0.944 when the next year reports come out, because we're not going down. This gap of 455 million tons of reduction that the industry needs to meet our climate goals, to actually sustain or actually have a sustainable textile industry for the matter. Because if we miss this target, no amount of anything else we do is going to still end up giving us a sustainable textile industry. We're going to have very high functioning fibers and whatnot, but we're not going to be sustainable industry. We're still going to reach all of our climate targets. So now we need to get to 455 million tons. If we go back to the previous slide, and then we just look at materials. So materials make up what, 208, 209 million tons. We need a 455 million ton reduction. So of course, this is not enough by any means. Even if all the materials became carbon neutral tomorrow, somehow magically, which we can never do, of course, we would only be able to reduce 208 million. So of course, we need to do other things. And that's where the picture comes in, is we have so much more emissions in the other side and so little on this one side, yet we focus so much of our resources in the pursuit under the name of circular economy, even though while leaving out almost everything else. So if we go, this is my favorite slide of the presentation for that matter. So we look at fashion and apparel emissions, about 944 million tons. Let's say the industry's overproduction average is 20%, 15, 30%, whatever it is. Let's take an average of 20%. That amounts to 188.9 million tons of CO2. And the fashion and apparel emissions, if you break it down based on material share, we have 208.7 million tons. So we overproduce almost the same amount of carbon emissions as equivalent to all the raw materials that we use. And we focus on this part. And the other part is something that we do unnecessarily, which gives us no value add. It is just waste of resources, money, chemistry, water, energy, everything, social labor. And then we're also worried, when we look at the social side of things, people are overworked and underpaid because you're overproducing things. If you were producing less, people would have to produce less. But you would also save money because these products would not go to waste as much. So you effectively get more money and have to work less, which solves the social problem of not having to overwork and underpay. But of course, nobody wants to touch the issue of overproduction for that matter. But just to show context in terms of what the scale of proportion of our solutions and what we think as an elephant in the room, there's a herd of elephants and there's so many of them, and we're choosing the one that's most convenient to us for that matter. But then, yeah, to put into context, we looked at the supply chain emissions, it made up 78%. So I will just take an example of just the Indian textile industry for that matter. And as we can see, we use a significant amount of energy. Most of it, just if you look at the textile finishing, which uses 43% of the energy for the entire industry, it's driven 81% by coal. And I'm sure everyone in the audience would agree that coal is a linear fossil fuel or linear fuel source for that matter. Solar and other renewables are more circular, not 100%, there's almost nothing 100% circular, but much more circular because the fuel source is regenerative. You burn coal, it creates energy, and then it's done. You can't do it again. But with solar, you set up the panel, the sun rays come, and it's a free infinite source that's going to keep coming, and you keep regenerating it. Of course, you're not the amount once the electricity is generated, you don't get it back per se, but because the fuel source is infinite, it becomes a circular fuel source for that matter. And we have technologies that can do this. So if we were to just look at the emissions of just India from this, it's 49 million tons, which is one fourth of the overall material impact or material impact that we have from the India's industry. All of this 49 million tons can actually be taken away through electrification. And there's a phenomenal report by Global Efficiency Intelligence. It is available on my LinkedIn. Otherwise, you can look it up as well. And all of this can be reduced at a much significantly lower cost. And that is what I'm going to go into. Is within the study, they looked up, for a typical facility or for, regional levels, cluster levels for the entire country, if we were to transition all the steam generating aspects, which is one of the biggest energy consumers within the textile industry, and we move away from fossil fuel based to either electric ones or heat pumps or something else, it's going to cost us for the entire country, India national level, $5.64 billion. Sure, it's a big sum, but I would love to put it in context of why this is not as big as we might think. So if you go to the next one, this was some of the industry reports that have come out in recent times for the estimates for setting up recycling capacity within Europe. We're going to expect to use about 5 to 6 billion euros to set up capacity for 2.5 million tons, which is also a big number. But when you look at the 132 million tons of material that we use, 2.5 million tons is nothing for that matter. It's a drop in the bucket for them. And then if you look at the capital expenditure for electrifying with heat pumps, it's $4.85 billion. So of course, in the previous slide, it was $5.64 billion. Now it's converted into euros. So it's still lower than the same amount. But now to put it into context, because of course, this looks, oh, we're spending the same amount of money roughly, but what's the impact? So based on EcoInvent and the other databases, PET has a carbon footprint of about 3.12 kg CO2 equivalent. And most recyclers claim at roughly a 50% reduction. Some are lower, some are higher. Higher ones I'm very skeptical about in terms of getting that reduction, but let's take an average of 50%. So if we were to calculate, we have 2.5 million tons of PET that we're going to recycle, let's say, for example, and we have a carbon footprint and there's a 50% reduction. All of that recycled PET is going to save us 3.9 million tons of CO2, which is a lot, but we need 455 million tons of reduction to meet our goals. Not 3.9 million is 1%, less than 1%. But if we were to look at this, so this is what $5 to $6 billion buys us. But if we were to look at, if we were to save the same 3.9 million tons of CO2, converting in an average size factory, going from a coal boiler to a heat pump, for that matter, is saving us 23,000 tons of CO2. Not just that, it saves us 23,000 tons of CO2. It gives out no fumes, so it's a very safe working space for people. It curbs air pollution in the nearby factories. It has a whole lot of other environmental benefits that come along with this. So if we were to save this 3.9 million tons of CO2, and we have every machinery upgrade is saving us 23,000, we would need about 169, 170 upgrades for that matter. And as we looked in the previous slides, the cost of putting up this heat pump kind of technology or electric boilers for a single facility, it requires about $5 million. So for 170 facilities, we're going to require about $845 million, which is 726 million euros. So in the previous slide, we saw that we needed almost, if you go back, we need about $5 to $6 billion to set up this 2.5 million tons, which is going to give us 3.9 million. And electrification, if you go back ahead, we're going to only require 726 million euros. It is a 7.5x differential. You could get 7.5 times more impact. So if I multiply 3.9 million, multiplied by 7.5, that's 29.5 million tons of CO2. So it's all close to almost 30 million tons for the same amount of money. So one of the solutions is giving us 4 million tons, the other is giving us 30 million tons for the same amount of money. So of course, the industry doesn't have infinite money, and the whole aspect of people. A lot of people tell me, we have to have a hand-in-hand approach. We need to do everything together. That is, for a lack of better way to saying, that's garbage advice. You can't do both things together. That only works in infinite games wherein you have abundant resources, abundant people, abundant collaboration aspects. Everything's just infinite, and you can do everything together. But when you're building a structure, let's say you're building a building, you need to get the foundation first, and then you can build the fourth and the fifth and the sixth floor. You can't do both at the same time. It just doesn't work. And we have limited access to renewable energy, which is one of the, while no recyclers might be actually saying this, that is the key to all of their solutions working out. All of recycling technologies have a very high energy footprint. Some of them have lower, they've optimized it, some catalysts and other things, but they do have a very high energy impact. And most of the LCAs that you might see and come across, they're plugged into phenomenal renewable systems, which don't necessarily exist in Asian countries as of now. And if you were to look at the electrical consumption that they would have, the amount of renewable energy we would need to supply to have these facilities to have, only just 5 to 10 million tons of materials, which is the goals for 2030 and around that mark by different organizations. We're gonna we're gonna have, if I were to divert the same amount of renewable energy that's gonna go to these fiber factories, to supply chain factories, I'm gonna get a 14x more impact return. So it's not even a close enough question that, oh, it's a 1.52 is the benefit. It's a 14 times benefit in impact reduction. So we need to prioritize some things in order. But now that we've looked at that, how supply chain decarbonization and everything else is exponentially much better use of resources, why do I promote the whole within the circularity aspect, the supply chain decarbonization? So I don't know how many brands there are. I can't see the audience as such. I want to raise a few questions in terms of all the circularity strategies that most brands have. The first question being, of course, does the supply chain capture and reuse the heat generating during production, or do you just let it vent out in the atmosphere? So that takes care of the energy part of things. Does your supply chain have advanced filtration techniques to upgrade the wastewater in your facility and reuse it multiple times? That takes care of the water aspect of things. Does your factory use green chemistry principles to reduce the overall consumption of chemistry, reduce the wastewater load? That takes about the chemical. Does your brand guarantee a living wage for all the workers within your supply chain, ensuring basic cost of living and everything else, and proper working hours? That covers the social. So there is more components, and material is, let's say, the fifth component of this. So there's energy, chemicals, water, social, and materials. And material makes up a very small percentage of this. And if the answer from most of the brands sitting in the audience, if the answer to all of these questions is no, you don't have a circularity strategy. That is just plain and simple. You don't. And good on you did a report about all the significant large scale brands. 84% of the brands don't even have a water target to begin with, let alone a strategy to recycle it somehow. And if recycling is such an important thing, why are we not recycling the most important resource that we have on the planet? We can't survive without water, but we can survive without more fibers for that matter. And I'm sure even if we don't do much, even if we let the material scale up and keep going business as usual and do the other things, we're gonna come within our climate targets. So even if I won't touch it, but if you don't save the energy and the water and the chemicals that you're unnecessarily using, and we come across so many of these reports, BCG, other organizations, the $500 billion opportunity from the circularity industry. That is the whole definition of opportunity is flawed in that perspective. Is opportunity has to be additive in nature. If recycled materials are to replace virgin materials, so circularity stakeholders who are the recyclers are going to get more revenue. The virgin stakeholders are going to lose revenue because they're not selling as much. So it's money moving from one to the other. It's not an opportunity for the industry. It's an opportunity for a select set of stakeholders on the circularity side. No problem with it. By all means, the people doing the right things should be able to earn more money. But let's not label it as the industry somehow magically going to get more money. They're not. And of course, we never consider the amount of money that we need to spend to set this up. They usually just take, oh, we have this 50 million, 100 million tons of material. We multiply that with the price of the material, $2, $3 on average. Oh, 200 billion, $300 billion. But that's revenue. That's not profit. And for it to be an opportunity, you need to be making money. For you to make money, you'll have to sell it at a premium, and that hinders adoption for that matter. And you need to get your capex back, which is, as we saw in previous slides, several $billion for only a few million tons. But if the brands actually want a $500 billion opportunity for that matter, it sits within your supply chain. It is not money you can earn, but it's money you can save. you're wasting millions of kilowatt hours of electricity every year without having efficient systems. So that's money being absolutely wasted for no reason. You have millions of megajoules of energy that is being wasted through different systems within the processing chain as well, with steam, unnecessary steam, other boilers, inefficient boilers. We're losing out on billions of cubic meters of water every year. Of course, water is not an expensive resource. Hence, if you do the monetary calculations, even if you were to recycle all of the water used by the textile industry, it'll be worth a few $100 million at best, not significantly, not the billions of dollars. But we need to understand that water is much more of an important resource. It being cheap has nothing to do with the value of the product. It is exponentially much more. Same goes for chemicals. We throw out hundreds of thousands of liters or cubic meters of chemicals out with the processing stream, with wastewater channels. We don't treat it. We pollute the overall environment. If we want to look at it, the cost of remediation of all of these toxic chemistries that have been put out would more or less across the entire globe go into several billion dollars, maybe even trillions of dollars if we were to look at PFAS chemistry and other ones. So there's a lot of other costs that we are not actually even considering because we see that it's beyond our scope. We're like, no, we focus on making products and that's what we do. And we're looking at, EPR, we need to take responsibility of our waste. Why does the ecosystem not have to take responsibility of their production itself? Why do we need extended producer responsibility? And I had this phenomenal discussion with Pauline from AI, and the word extended says that we are already being responsible and now we're extending our responsibility. But that would convey that we're already doing things within the supply chain in a responsible manner. But we barely do that. So there's no extension for the responsibility. We didn't even do the first thing. So maybe what we need to do is move to a model wherein it's better producer responsibility, not extended producer. You take responsibility for having a better production throughout the supply chain, and you build in circular principles everywhere. And just a fun thought experiment, if brands or anybody else wants to do, what is the most circular thing within your supply chain or the entire textile value chain? It will most likely be your factories, because the factories have upgraded for the last 3-4 decades so much. They reuse chemicals, they reuse water, they reuse heat to a large extent already. And if you wanted to create a circularity score for your brand, the highest score will come from your supply chain, not from your materials. By no means it will come from your materials. It will definitely come from your supply chain. So if you want a circular industry, maybe we need to bring these aspects, the questions that are there, and I have a significantly long list of questions, but I didn't want to have a very long pitch deck for that matter right now. I'd be happy to share. I'll publish it online as well. And maybe once we bring those questions into our sustainability reports, our circularity reports, and once we answer all of them, then maybe we can see if we're moving towards the right direction. Coming to the next one, of course, yeah, this is the big problem that we have, the elephant in the room. We see the 92 million tons of waste. Recently, a lot of stakeholders went to Ghana and other places, saw the landfills. It was devastating for that matter, and it is a big problem. But let's put it into context of the things that we don't see. So if you go to the next slide, and of course I have a star mark. I have a star mark over the 92 million tons for the matter that because we don't know. And Lutz Walter had done a recent couple of posts looking into the data from different studies and everything else, and it's a much lower value. But irrespective, we have a lot of waste, no denying that part. But if we were to look at waste overall, the atmosphere and the oceans are our biggest landfills, not the ones we see on land. By no means. We're seeing 92 million tons, 100 million tons, whatever the number be. If you were to just look at the emissions of the industry, so we looked at 944 million tons of the overall apparel industry's emissions. 20% of that was just overproduction, which is 188 million tons. Let's round it up to 200 million tons. So the fashion industry makes up 1.78%, just the apparel side, of the global emissions. So the overproduction part makes up 0.356%. I'm going to be throwing out a lot of numbers. I apologize. I didn't write this down. So 0.356% of the overall GHG emissions for the globe is coming from the overproduction aspect of the apparel industry. Now, if you were to monitor the different resource loss across the globe due to exaggerated climate change, which has happened over the last 5-7 decades for that matter, and if we look at how much resources we've lost, glacier lost, and crop yield lost, and weather events that are causing a lot of other problems, because we're looking at circular economy as a whole principle, not just materials, we need to look at all other resources. So all the other resources that are being destroyed yearly because of climate change pushing us to the limits, we need to then do the math of how much resource do we lose in a year, and and then we take 0.356% of that and then attribute it to the overproduction part. Of course, I can take it to the 1.78% and attribute it to the entire thing. I was just trying to do the math, and I will be posting it soon enough. I'm still in the works. The overall resource loss, just because of the overproduction component of the fashion industry, accounting for iceberg loss, crop failure, and everything else, is 3.5 billion tons. So 92 million tons of visible waste and 3.5 billion tons of invisible damage, visible damage, but caused due to invisible waste that we are actively putting out into the industry or the globe for that matter. So when we think, this is a big elephant in the problem, it is a very tiny elephant. And the fun part with all of these textile waste is, and why we need to focus on carbon emissions first, is if we miss our targets, and if you have products lying in the landfills in a very nice manner, let's say we create very good landfills, those products are not going anywhere. You can come back to it in 50 years with the most advanced technologies for recycling, everything else. Once we have the climate aspect in under control, you can return back to that waste and recycle all of it. Absolutely. But as my second line says, if we push our limits on the ocean and the atmosphere beyond the limits, there is no recycling capacity. We can't recycle it back to the original state. You can't pull it back. Once you have destroyed it, you've just destroyed it. But landfills are just materials stuck on a land, which we can do it in a very nice way. There's other waste management practices that are also ongoing. Maybe not the most efficient resource utilization as opposed to recycling, but it's going to take a long time for us to get there. And if we truly want a circular economy, maybe it's time we need to think bigger. And if we stay with our mindset, I come to my last slide. I don't know how I'm doing on time, hopefully good. And this is my hot take for the day and for the next 5 years as well, for that matter. And if we continue down this path of the strategy that we have and disproportionately pursue circular materials and not circular economy in its true nature, we can absolutely say goodbye to our 2030 climate goals, maybe even 2040 goals for that matter. And I would open it up to the audience for that matter right now. If anybody has any data to showcase how any of the circular material strategies are going to be scaled up and everything else and are going to be enabling us to meet our 2030 goals, I would happily welcome it. But I can say with a very good certainty, nobody would have any of those numbers because they just don't exist. And yeah, that is all from me. Thank you so much.
We show our appreciation for Shivam. Can I embarrass Shivam and give everyone a really good bit of news? I find it hard to keep up with Shivam. He has so much information, it's so much quality. No way can you take all that in. The brilliant news is in about 2.5 weeks' time, the whole of this presentation, so Shivam going on at twice the speed of light and his slides have a stop button. So you can play them stage by stage and go back. This is such high quality information, we need to take it in. But we've only given Shivam a certain amount of time to communicate it. He, to me, has come up with this double dividend protocol. And I look at a lot of theoretical principles. I'm really good at picking holes. Double dividend protocol, I can't pick a hole. It's not perfect. We've got to use it. We've got to try. We've got to see who adopts it. But whereas I hear lots of proposals around people saying, yes, we need to finance this, we need to finance that, this approaches it from the user end. And this is something that me personally thinks the whole trade should embrace. So Charles is filling in the hope that there are going to be some questions coming from the audience. Because there are people sat in this audience who understand more than me. People like Julie, who might take this on board. But if not, I get to ask Shivam the questions. So Shivam, I like everything you've said. I have already highlighted we've got to see what gets adopted, and so much of that is going to be over if people will collaborate the most. And we are so fortunate that the European Outdoor Group is full of cooperation and principles of it. But I want to ask you a tangential question, in that coming onto my radar now, I'm seeing a lot more about carbon and carbon accounting. And I know it's not part of your presentation, but we're now hearing stories about we should separate fossil carbon from biogenic carbon. I also hear really good arguments coming around saying we have too much carbon. It's a diversion to talk fossil versus natural carbon. Where do you stand on the position, matey?
Yeah, no, I mean, super nice question. And I think within just regular LCAs that are being conducted, of course, there is already a split between fossil carbon and biogenic carbon, and it is displayed in the overall sense. I think within the industry, we have certain challenges within the whole biogenic carbon aspect, because most of the natural materials, for that matter, during the growth phase and everything else, they do consume carbon. But of course, then we have certain underlying principles for us to be able to claim that biogenic carbon as part of the product itself. It needs to stay within the product for a set duration of time, and it is set at about 100 years. So if we make these products, and usually we don't expect our textile products to last for 100 years, especially the natural fiber ones. So of course, even if it consumes some CO2 and if it degrades at the end of life, it will give it back. So it's a net for that matter. So then only the production emissions are associated with the product, and the rest of it can nullify. So you can take it, but then you'll have to give it back. So then it's a plus one minus one kind of approach, or mostly the industry has zero zero and plus one minus one approach. So it is a valuable tool, and of course, if we have such certain cycles wherein the whole consumption pattern continues, we extract some, we give it out, and we extract again, and we give it out, and we extract. If the cycle continues really well, maybe there's an opportunity. But I think the whole definition and how they're conducted within LCAs is a bit strange at the moment, and nobody seems to have the perfect way to approach this, at least for the textile industry. Some other industries on the chemical side of things do make use of biogenic carbon. We haven't necessarily figured it out yet.
Okay, that makes good sense. I'm still looking for questions from the audience if anyone wants to dive in. And David's just joined us in the audience. If you don't know David, you need to listen to him when he says things on stand. Okay, Shivam, if I take it from a different philosophical point of view, whatever idea that you're behind is brilliant, but there's a hurdle, there's a hassle of why we're not doing it. If you had a magic wand that you want to communicate to the outdoor and sports industries, where do we need to change most? What is stopping all of this happening? What barrier have we put up there that we hide behind, which is just a pathetic excuse?
This is a fun one, actually. I did a post just before coming for this session, and it's about the whole aspect of data. And we hear from everyone, data is scarce, and we don't have all the right things and everything else. That is just a sad excuse that we have. We need to define how we define all of these aspects. Is the industry has a lot of signals. So signal is just information that is coming out, for that matter. So when 1 kilowatt hour of electricity is used by a machine, it uses 1 kilowatt hour of electricity. How does that translate into data is when we actually have a means of measurement, and we put up a sensor or a meter, and it calculates, oh, it's 1 kilowatt hour energy. Now I have a data point. So if the industry says that we don't have data, doesn't mean that the data does not exist. We don't have a means to measure it, or actually, for a better way to say, we have the means to measure it. We're just not measuring it right now. So we say, oh, we don't know, the supply chain is too fragmented and everything else. But if you enforce rules and other things wherein everybody has a mandatory requirement to get the values on a per factory, per day, per kg, per batch, every different levels, which is easily accessible and can be done, and sensors actually don't cost that much as well. With a few $1 billion, we could actually more or less get sensors for almost all the factories within the textile supply chain. Would cost much less than any other measure that we do. And I was speaking with Phil as well, Phil Patterson, recently. And there's a lot of brilliant factories across the globe, India, China, other places, which run state-of-the-art systems. Every single metric that needs to be plugged in for DPPs, LCAs, whatever it be, they have access to all of it on a computer screen which runs live. And you have a 5-minute or a 15-minute interval for collecting the data. So one thing, if the industry wants to improve upon, is stop hiding behind the aspect of, oh, we don't have data. Ask yourself the question, what have we done to get that data in the first place? And if you haven't done anything, you can't use the excuse that we don't have the data, because you didn't try. Because if you would have tried, you would have had the data. And if you would have the data, you would have done something about it.
And I think that's a cautionary tale that we should all take back to our employees. I'm still looking for questions, but if there are no questions, are there, Mark? Can I ask us once again to show our appreciation for Shivam?